Okay, so miscellaneous exercise of integration, question number 27. Integral 0 to pi by 2 cos square x dx by cos square x plus 4 sin square x. Like previous question, if you do substitution for cos or cos square or sin square, you don't get the derivative properly in the numerator. That is a problem for us. So this type of questions where you will see in numerator and denominator cos square and sin square, you can make a try with the sec square or sec power 4. That is a type question. Why do I say this one means, if you get a tan in denominator and c square in numerator, you can put a tan x as t and c square x will become its derivative. It may be little vague, right? When I speak like this, you see what I do. I'm going to multiply. If I multiply sec square x in numerator and denominator, this cos square and c square will cancel, it will become 1. That I don't want. I want a c square. So I multiply a sec power 4x in numerator and denominator. Sec power 4x. Now, this will become integral 0 to pi by 2. Cos square into sec power 4, 1 cos square and 1 c square will get cancelled. They are reciprocal functions. So the remaining there will be a c square x dx divided by, now similar fashion this also will become sec square x plus 4 cos square and this will become sin square and c square will become tan square, because sec square is 1 by cos square, tan square x, and then c square x is left over, that will be like this. Now what do we do? Now if I put tan x as t, its derivative c square x dx is here. I am happy, but this makes me unhappy. See, sec square x here, c square. What do I do with that? I want the derivative c square in the numerator only, but in denominator. Then I use my 10th standard formula. C square can be converted as 1 plus tan square. See, remember, sec square x is 1 plus tan square x. So if you put tan x as t, sec square x dx is equal to dt. So I will write this integral, this will become dt divided by, this sec square will become 1 plus tan square, that means 1 plus t square plus 4 tan square is t square. This I can write 1 plus t square. Children, see, c square I convert as 1 plus tan square. I didn't write that step, but I can take it as 1 plus t square because tan is going to be t. Now, what do you do is, we'll put the limit. We can put limit tan 0 here, 0 tan pi by 2 infinity, like that. So we can put that. I'm not doing it right now. Let me attend this work. So integral 1 by, this will become 1 plus t square plus, this if you multiply you will get 4t square plus 4t power 4. Okay, so this is how we reached this much dt. Now this can be further written as 1 by, let me write this 4t power 4 first. 4t power 4 plus, this is 5t square plus 1 dt. 4t power 4, 4t square and t square will become 5t square plus 1. Can we factorize this like a quadratic? Because here it is a quadratic in t square. T square the whole square, t square. So when you add you should get 5, multiply you should get 4. Which are the numbers? They are obviously 4 and 1 itself. So I will show that. What I will write is 4t square plus 4t power 4 let it be, and 5t square plus 1. This I am going to write it as 4t power 4 plus 4t square plus 1t square plus 1. I splitted it. You know that technique. So you take a 4t square common factor from the first two terms. What is left? T square plus 1 plus, from here I will take a 1 common factor. t square plus 1. Now from this term and this term, t square plus 1 common factor into 4t square plus 1. Now the denominator got factorized. So the next step onwards, I am going to write it here. So let me erase this part. This you keep it in mind. Okay. We will apply the upper limit and lower limit will change. But for the time being, let us take this place. And we will write this as integral 1 by, what did we get when we got t square plus 1 and 4t square plus 1 dt. This is how we factorized. Now how do we do this one? Obviously partial fraction. Partial fraction, when you do, both this are t square. So you can do a small replacement for t square as u, and you can do the partial fraction work to find a and b. Then we will come back to that. So let me write that step over here like this. This is where we reached. Now what I do is, I will write like this. What I do is, for time being, I'll put, it's not an integrated substitution, we just will put t square is equal to u. So this will become 1 by u plus 1 into 4u plus 1, which I can write by partial fraction method by u plus 1 plus b by 4u plus 1. Now multiply the denominator of the question all through. Then all through, if you multiply, this will get cancelled. 1 is equal to a into u plus 1 cancel. What is remaining is 4u plus 1 plus b into 4u plus 1 cancel, u plus 1. So now we will put u equal to minus 1. So we will get 1 is equal to a into 4 into minus 1 plus 1. This is 0. That is what we put. What was our aim to write here? What? T as minus 1. Now I will get this finally. A will be equal to, this is minus 4 plus 1 minus 3. So minus 1 by 3. Now I will put u is equal to minus 1 by 4 to make this one 0. So I will get 1 is equal, left side there is no u to substitute, which is equal to b into minus 1 by 4 plus 1. So that will become 1 is equal to 3 by 4b. So b is equal to, cross multiply, you get 4 by 3. Now I will write this like this, integral. So this will be a by u plus 1. What is a? A is minus 1 by 3 by u plus 1. U plus 1, what is u? U is t square. So t square plus 1 dt plus b. What is b? 4 by 3. So 4 by 3 by 4u plus 1. 4u plus 1 means 4t square plus 1 dt. This you can integrate separately. So this will be minus 1 by 3, 1 by a tan inverse t plus 4 by 3. Here this is 2t square. 4t square you need to convert as 2, or you need to read it as 2t square plus 1 square. And this is 4 by 3 is already here in the numerator. So I need to write 1 by a. What is 1 by a? 1 only. Since the coefficient of x, here x is t square. So in the place of x. So that is not 1, it is 2. So you need to divide by a 2 here. For what? For 2t square plus the whole square plus 1. Then tan inverse 2t by 1. So if we write, we will get minus 1 by 3 tan inverse t plus, this you can cancel this 4 and this, you get 2. So plus 2 by 3 tan inverse 2t. Now let us apply the limit. What will be the limit? You remember for what we put as t? T was tan x. tan x is equal to t. And what was our limit in the question? You look at the question. If you look at the question, this limit was 0 to pi by 2. So when x is 0, t will become tan 0, that is nothing but 0. When x is pi by 2, tan pi by 2 will come. Tan pi by 2 is infinity. For this will become infinity. Okay. Now we will apply the limit. So when you apply the limit, minus 1 by 3. When you apply infinity, tan inverse infinity. Tan inverse infinity is pi by 2 only. Plus 2 by 3. Here tan inverse 2 infinity. That also what only? Pi by 2 only. 2 times infinity or 1 time infinity. Infinity is infinity, that is pi by 2. This minus, if you apply 0, tan inverse 0 is 0. Both the times it will be 0. So that place you can ignore. So this will become our final answer. What is this final answer? Minus pi by 6 plus pi by 6. So both are, minus pi by 6 and 2 pi by 6. So final answer will be just pi by 6. Here 2 pi by 6, here minus 1 pi by 6. Therefore, final answer is plus 1 pi by 6. Your final answer is just pi by 6. This is our final answer. Okay. It looks a bit lengthy, but you practice the substitution, converting into partial fraction, dealing with that, and ultimately you get this. Okay.